In this video, we're going to look at a hypothesis testing about the difference of two means. Recent video I talked about I'm beginning to consider whether I wanted to enter private tutoring again, and I'm looking to, in the previous video, I wanted to make at least $75 an hour. Found that, based on the data that I'd found, I can't do that, but I'm curious. I had surveyed 72 parents, and I found a mean amount that they were willing to pay as a group. And as I looked at the data that I had, I realized that some of the parents included in my survey were parents of middle school children, and some of the parents were parents of high school students. And so I wonder if there's a difference in the mean amount that the middle school parents or parents of middle school children are willing to pay compared to the parents of high school children. So notice of the 72 parents that I had surveyed, 38 were parents of middle school children, and the other 34 were parents of high school students. The parents of the middle school children were willing to pay a mean of about $56 an hour with a standard deviation of 10. Now that standard deviation of 10, notice, is the sample standard deviation. I don't have a sigma, a population standard deviation. And the parents of the high school children were willing to pay a mean of about $82, and again, a sample standard deviation of 12. I'm assuming that given the fact that secondary school age children are closer to going to college, they're studying more difficult material, parents may be willing to pay more. So I can do a test to determine whether those amounts, the average amount that the two groups are willing to pay, is different, where one is greater than the other, one is less than the other. So to do a hypothesis test on the graphing calculator, I'm going to go to Stat and Tests. Now, numbers 1 and 2 are for tests of mean if it's only a single mean. Here we're looking at the difference of two means. So I'm going to use either number 3 or number 4 to sample test. I'm going to use the two sample z-test if I know the population standard deviations. Since I do not, I'm going to use the two sample t-test. Okay, so we have stats. We don't have actual data. We have our stats. We have X1. So my group 1 is going to be the younger children, the middle school. That's my younger children there. So X1, there were 38 parents surveyed. The mean was 56 with a standard deviation of 10, and there were 38 of them surveyed. For the parents of high school children, the mean was 82, the standard deviation was 12, and there were 34 of those parents surveyed. Here you do want to be very careful about the order. I want to test whether the parents of high school children are willing to pay more. That immediately makes me think of greater than, except that my group 1 is middle school. So if the parents of high school age children are going to pay more, that means that the parents of middle school age children would pay less. And that's why I'm going to select mu1 is less than mu2. Okay, so you want to be very careful of your wording there. Pooled, very quick summary there. We've talked about this. Hopefully you've talked about this in class. If you're taking a statistics class, that the the pooled would be the two different groups. Can we reasonably assume that the population proportions are the same? I don't want to get into that, so I'm just going to conservatively leave this as unpooled and leave it as no. So I hit calculate, and notice here's our information. T is huge, P is 0.000, okay? So I can conclude that, in fact, there is a difference. In fact, there appears to be an extreme difference because my P is so close to 0, the calculator actually says 0. So I can reasonably conclude that the parents of high school age children are willing to pay more than the parents of middle school age children. There's more information down below, which is simply just the ends. So all of this here is simply the calculator repeating back my X1, X2, SX1, and so on. So I can conclude that there is, P is 0, P is 0.000. I can conclude that there is a difference in the amount that parents are willing to pay. So there's the hypothesis test. If I want to move on and find a 95% confidence interval for the difference in the population means for the amount that parents are willing to pay, my test says that there is a difference. I wonder what the difference is. Stat. I'm going to go back to tests. But where I just used number 4, the two sample t-test, I'm now going to go down and look for the two sample t interval. And that's going to be at number 10 or number 0. have the 2 sample t interval. I select that. Just like in all the other things, the calculator will pull in. My x bar 1 was 56. My SX1 was 10, 34, or 38. You see all that data there. I want to find a 95% confidence interval. I did my test unpooled, so I'm going to do my confidence interval unpooled, calculate. And so what I find on average is that the parents of the middle school age children are willing to pay, on average, somewhere between $31 and $21 an hour less than high school parents or parents of high school children. And so that gives me an idea of which one do I want to tutor and how do I want to look at that data and how do I want to employ that. So there's a quick look into hypothesis testing about the difference of 2 means using the graphing calculator.